Hello, testing, testing. Strings. You're given an array of strings, products, and a string search word. Say what? You are given an array of strings. You are given an array of strings, products, and a string search word, okay? Design a system that suggests at most 3 product names from products after each character of search word is typed. Suggested product should have common prefix with search word. If there are more than 3 products with a common prefix, return the 3 lexicographically minimums products. Return a list of lists of the suggested products after each character of search word is typed. a list of lists. Say what? So products is this, search word is mouse. So I guess you could return a mouse or a mouse pad. Output is mobile, money pot, and monitor. Say what? So give me a second. I think I disconnected before. I wonder if I'm back though. Okay, apparently I'm still streaming to the same stream. That should be a good sign. Alright. Sick, I'll take it. Okay, so the input products is this thing. The search word is mouse. I would expect that you would return mouse and mouse pad. Oh, is it per... Is this per letter? So when you type M, it's mobile, money, pot, monitor. When you type MO, it's mobile, money, monitor. Oh, I see. MU, it's mouse and mouse pad. Mouse pad, mouse pad. Oh. Explanation. Product sorted lexicographically. Mobile, money, pot, monitor, mouse, mouse pad. After typing M and MO, all products match, and we show user mobile, money, pot, monitor. Okay. I see. So it's per letter. After each character of search word is typed. I see. This feels kind of similar to the problem we did last time, no? So over here, the list of product is Havana. Well, that's it, Havana. Search word is Havana. So you just keep returning Havana, right? Yeah. Seems like a try problem, no? So basically you're given a list of products like that. And I think we should construct some sort of try with this. So in this try, maybe we'll have like a M, and then an O. Is it even worth my time to try drawing out this try? Like M-O. Okay, let's say we're one by one inputting all these products into a try. So first be mobile. M O B mobile. Like that. Mobile. Okay, I remember a strategy last time was to literally store every sentence in like every possible word, I guess, in each node. So for example, mobile in M, you would actually store the entire word mobile in the list of like the list of words that pass through here, and then you would store it for every single node. And then if you input mouse, M-O-U, U-S-E, so over here, mobile, you would also store a mouse. And then from here onwards, you would just store mouse, right? I've always been kind of questioning if this is the right move, even though it was the Leetcode solution last time. It feels like we're wasting a lot of storage, no? Because for every node, we could be storing every single, worst case, every single product, every single word in the product. But But at the same time, if we don't do this, let's say we start at the top, right? And we're asking ourselves, what could be, what are our best matches given that we just typed M? We would have to DFS all the way down, you know? That would be like n time, where n is the number of nodes in the trie. So maybe this is worth it. Otherwise, you would have to do like some sort of DFS all the way down. I guess your recursive base case would be like, if you're at the leaf node, then add the sentence ending at that leaf node into your list of stuff that you're considering. And then you would sort all those lexicographically. Yeah. And then return the top 3. But yeah, I can see that's like O of n time if n is the number of nodes in the trie. Maybe it is kind of worth the trade-off of the storage. Storing every single word that passes through each node. You know what? I'm going to try that strategy again. I think it's worth it. Let me just take a peek at the solutions to make sure I'm even on the right track. So it says, approach to trie plus DFS. Oh. Okay, so they're going with the DFS method. A trie word is presented by its pre-order traversal. Questions using trie. Create a trie from the given product's input. Iterate each character of the search word, adding it to the prefix to search for. After adding the current character to prefix, traverse the trie pointer to the node representing prefix. Now traverse the tree from the current pointer in a pre-order fashion and record whenever we encounter a complete word. Oh, interesting. Limit the result to 3 and return DFS once reached this limit. Add the words to the final result. Interesting. So in the solutions this time, they're saying actually do a DFS. Don't actually store this every word that goes through each node. Why though? Somebody says, I don't think the time complexity of the second approach is trie plus DFS is O of m time. In the worst case, for every prefix, the trie needs to be traversed for once. Somebody says, in optimization for trie solution, no need to DFS every time. Just keep an array of up to 3 variants per every trie node. Then just pick variants from the trie nodes as you walk down search word. Additionally, variants should not be products themselves. Just keep indices there. Variants should not be products themselves. What? Then pick variants from the trie nodes. Maybe he's saying the sentences. Somebody says, then you would have to sort the words up front so that the order of the indices is lexicographically correct. DFS is the best approach here. To remove the m squared complexity that we have due to passing the prefix / word while doing DFS, we can store the word itself at the final node. I don't know. I still feel like storing it at every single node, storing all the words that pass through every node in each node is much faster than that. No? You know, I think I'm gonna still do the technique we learned last time. I think that's valid. I'm gonna do the try method, but at every node we store, you know, every word that passes through it. Returns a list of the suggested products after each character of search word is typed. I feel like that prevents us from doing a DFS, right? We'll just stop at the current node, get the current list at that node, sort it, and then that's the answer, right? You know what? It'll help me practice and review what I learned last time too, so I'll go with that method. Does that make sense? I feel like it does. Okay, here we go. So the first step is to take all the products here and then put it into a trie where all of the all the nodes contain a list of all the words that pass through it. And then for every word in search word, we'll just step through the trie using a current node and I guess sort the list of stuff in that current node and then return it. I don't know if that makes sense, but it makes sense to me. Okay, let's make a class. This is class solution. Can I make a class node here? Would I even be able to use it in the class solution? Wait, let me check. You know what? Screw it. That's what I'll do for now. So in a trie node, you're gonna have a init function, define init. Clarity, I'm gonna say trie node. This is gonna take in maybe the current value of the trie node. So you're gonna have a self.init self.value is equal to value, and then it's going to have some children too. So self.children is equal to a hash map of the characters mapped to their corresponding trie node, and then we'll have the list of words that pass through here, I guess. So self.words is equal to just a list, I guess. All right. Should this be like a... Oh, I don't know what the equivalent of a priority queue is in Python. We can for sure sort the words as we place them in each node, right? Maybe I'll worry about that later. Okay, suggested products. Oh, should we also have a function that inserts inserts a word into the current trie node, like starting at the current trie node. So we can just call like root dot add word, you know? Should that be inserted here or here? You know what? I'll do it here. Define add word starting at the current node. Okay. Okay, so for every character in the word, we have to check if our children contains the next letter that we're looking for. Yeah, and if it doesn't, we have to add it in. So if self.children does not contain if the character is not in self.children, if the character is not in self.children, then you have to add a new trie node representing that character. So self.children with the key character is equal to a trie node of C. Yeah. And then at this point, you're guaranteed to have a node corresponding to that character. So you would get that node, right? Child and node is equal to self.children getting C. Yeah, and then once you have the current node, you would add the word to its list of words, right? So node dot current node dot words dot append the current word. Yeah, and then you would iterate again, but you would use your current node as the new node that you're iterating on. So we probably need to track node up here too. Node is equal to self. Is that how you do it? Python how to refer to self in class function, instance in class function, self, you include self as the first parameter. Is it actually self? Oh, maybe these need self too. Self word. Node is equal to self. Okay, I think that's how it works. Node is equal to self for every character in the word. If the character is not in self.children or the current node.children. Oh. My Bluetooth headphones are running out of battery. Let me go charge them. Okay, so if C is not in the current node's children, then self, there should be node too. Then the current node's children, C is equal to new trie node C. And then the current node is now equal to self.children c node.words.append word. And then you go back up here for c and word, and node will be the next one. Yeah, I think that's it. Cool. So what I have to do up here is I have to make perhaps a root node. And root is equal to new trie node with value root. I'm just going to do a sanity check first. Let's do root dot add word. Let's do ABC. And let's just print root dot children the first one, or take a dot value, and then we can take root dot children a dot children b dot value. So this should print AB, hopefully. Let's return a bogus value for now. Submit. Please work. No. Node is equal to, oh, that's just wrong. This should not be self, right? Node is equal to the current node.children c. None is not, oh, lowercase. Wow, we actually did an AB. No way. Okay, let's make sure B has the right children too. So children A, children B, dot children C, dot value. Cool. Okay. I almost can't believe it. We implemented a trie. Okay. So all we have to do now is for every single product. Oh wait, I should also... Oop. I also want to check the words stored in each trie. A dot... Let's do A dot words, B dot words, and then C dot words. ABC, ABC, ABC. Okay, let's do like ABD. ABD. So it should store ABC and ABD up till A and B, right? And then C and D should store different stuff. Nice, okay. Cool. I feel like this trie actually works. This is really good. Okay, so now all we have to do is for every single product in the trie, we add it into the root node. Okay, so for every single product in products, root.add product. Okay, I have confidence this works. Root.add product. And then now all I have to do is process every search word for every character in search word, excuse me, there's only one search word. For every character in search word, we would have to iterate down the root, right? So we'll have a variable to store the current node in the trie. We'll set it equal to the root at first. Root. For every C in search word. Actually, what happens if there's no solution? Suggested products should have common prefix with search word. Okay, I guess I'll worry about the non-existent case later, but let's worry about the basic case first. For C and search word, first we have to get the actual node. So node is equal to C is equal to the current node dot children get C. We have to return a 2D array of our results, right? And then results is equal to a list. Node is equal to node.children C. So then we'll get the list of words at that current node. We'll sort it and get the top 3. Result, this is just one result, is equal to node. So why did I wrap this in string? It should be just a variable. Result is equal to node dot, my brain is not braining right now. Result is equal to node dot words, and then we have to sort it. Dot sort. Is this how you sort stuff in Python? Python sort list in place. Hello Gamer says, yo, hello, how you doing? Dot sort. Oh, okay. It's just dot sort. Hello, hello Gamer, how you doing? I'm trying a try problem. So nodes.words.sort, and then we'll have to get the first 3 of these, so index 0 to 3. But we also have to be careful of the case where there's not 3, like the length of the list is less than 3. So maybe we'll have to do like length min 3 of length of node dot words. That looks so complicated. Hello Gamer says, good, and how you doing? I'm doing pretty good. I had a nice work day today, meaning it was short and I got stuff done very early. Yeah, my workplace. Oh, I realized the chat is in front of me. Let me fix that. Yeah, my work office actually moved recently. I work at a startup. We recently moved to a different office. It's like a really new office, so we're basically the only startup that's working in this building. Even though we only have one room, it feels like we have the entire building to ourselves. Ooh, who is this? Badoli head chicken. Battle chicken? Badoli head kitchen. I feel like katakana is one of those things, if you read it fast, you're more likely to understand it. Badoli head battle hen? Oh, well, hello. Tell me how to say your name, please. I suck at katakana reading. Okay. Okay, I'm still trying to make sense of this line here. Basically, I'm trying to get the list of words at each node, sort them, and then get the first 3. This syntax is so complicated. So first we get the list of words at the node, we sort them. We want to get the first 3, but we want to be careful in case our index is out of bounds too. So you have to take either the minimum of 3 or the length of node.words. I feel like that makes sense, right? If the length is 2, that means it goes up to indices 0 and 1. 2, so it's 0 to 2 exclusive. So you still take indices 0 to 1. I think that makes sense. Hello says, are you graduated? Yep, graduated a long time ago. How about you? Are you still in school? I feel like most people who watch me are still in school. And then over here, results dot append result. Lexicographically minimum products. By lexicographical, they mean alphabetical order, right? Ascending order? Mobile, yeah, this is ascending order, okay. And then I'll just return results. Let me run this. Try node object has no attribute add. Oh, it's add word. I forgot the function that I defined myself. None type object is not subscriptable. Oh, where is this? Node.words. In mouse? None type object is not subscriptable. So we're trying to subscript. Dang. Oh, I see. Because sort doesn't actually return anything, right? It just sorts the list in place and returns nothing. So we should get the current node. Oh, I see, I see. Let me make this visual smaller. I'm such a Python noob, man. Okay. So we should sort this in a different line. We just say node.words.sort. So that'll sort it and it will return nothing. And then over here we'll make a fresh call to node.words, and then we'll take the first three. Let me check if I'm doing Python list comprehension correctly. List comprehension. I am in university first year. Ooh, go look, man. Maybe this is a good time to be first year in university. Cause it's like, no way, I got it. No way. Okay, I feel like these tests pass because the test cases they gave me are really crappy. What if they gave me... What if the word they gave me, it contains letters that are not in our trie? Then we're screwed, right? We have to watch out for that. Node is equal to children C. Maybe we have to do a check first if the character is even in the trie. But yeah, I was saying, maybe it's a good time to be a first year in university. Because like, who knows what will happen in 4 years. The job market is really bad for right now in CS. Maybe you guys will wait it out and it'll be way better in like 4 or 5 years. And maybe the AI bubble has already popped and recovered. Yeah, it sucks to be looking for a CS job right now. And you might even be able to do a master's or PhD and wait it out even more. So, yeah. So if C not in node, the current node's children, then we're kind of screwed, right? Then we just return results immediately. Break. My course is AI and machine learning. Am I cooked? No, you're not. Well, you shouldn't take my opinion as like the rule, because I don't know much either. But I would say no. AI is going to be the future, right? AI is going to automate everything. If you can't beat him, join him, am I right? Join the clankers. When the clankers take over the world, you're the one coding the clankers. Your job can't be automated, right? If C not in node.children, then we break automatically. Yeah, that should be the move, right? Because otherwise we definitely will not find the other letters in the future. Yeah, this is accepted. Okay, let me add my own test case. Clone current test case. What do you mean join him? If you can't beat him, join him, right? Like, they say AI is gonna automate all the jobs in the future, right? But somebody still has to make the AI, right, to automate those jobs. So the best plan is to join the AI. Be the overlord of the overlords, you know? Be the mechanic of the AI so they cannot dispense you. Isn't that a flawless plan? Absolutely. Absolutely flawless. Okay, if I do MABB, then it should just return one array in the results, right? And then everything else will be empty. MAA, yeah. Oh, you mean you want me to operate the AI? Operate the AI? Maybe. I was thinking more so coding the AIs. Oh, I see. Then you just add nothing. That's what you do, okay. Okay. So instead of breaking, I should continue. I still want to continue the loop. Continue. And then results dot append an empty list. Okay, screw it. I'll just submit this. No! Why? No! How am I supposed to debug this? My Python course is going to start from December 15. Do you have any tips for Python? Do I have any tips for Python? I think I learned Python just by like learning it in class. I guess just pay attention in class. If they teach you how to trace out Python frames, pay attention to that, I guess. I feel like that's really useful information to know. Yeah, I guess I don't have much advice except for pay attention in class. Whatever they teach you, it will pay dividends. Why is this wrong? My output is to be honest, in class I feel sleepy. Oh, I have that problem too. My head keeps like bobbing up and down, right? I have no idea if there's a cure for that. Yeah, I don't know. I have the exact same problem. Sometimes in class it's so boring. Okay, what's up with this? Output expected. Wait, my solution is so close. Why is it wrong? It's literally right up to here. Wait, what if I just Control F here? Okay, what if I just Control C this and Control F it? Control F. It's literally the same. How am I supposed to debug this? Should I just... Let me use this test case. This feels so bullcrap. Should I just say... Should I just accept this as completed by me? I mean, at this point... Whoop. I pressed the wrong button. Submission rejected. I love the Elden Ring extension. I mean, at this point, I feel like I would have just passed it during a real coding interview. It's impossible for me to debug this too, because the output is way too long. I mean, I could debug it, but it would just be a lot of effort. I have to print it out myself. See, it's exactly the same. These two outputs. You know what? I think this is one of those cases where it's like, it's good enough. It's good enough. In a real interview, they would let me pass. I think. But yeah, I'm still gonna read the actual solution. Okay. Let's do some reading then. Yeah, Hello Gamer says, in class I feel sleepy. I have a solution for that at work actually, because I'm a working engineer right now. See, when I feel sleepy at work, I just take a walk outside, do some squats. Yeah. You know, that gets the blood pressure going. Hello says, yeah, give me. Wait, give you what? They say use try and DFS here. Yeah, I don't know how you solve that. Can you just leave in the middle of class and start doing like exercise, push-ups outside the classroom? And then come back when your heart is pounding more? I feel like I've done this probably, no? Okay, probably not. Okay, try plus DFS. This is the answer key. Intuition. Whenever we come across questions with multiple strings, it is best to think if try can help us. Yeah, it can. The question also asks for a sorted results. If you look closely, a try word is represented by its pre-order traversal. A try word is represented by its pre-order traversal. I totally forgot what that means, pre-order traversal. It is also worth noting that a pre-order traversal of a try will always result in a sorted traversal of results. Thus, all we need to do is limit the word traversal to 3. What's Trie pre-order traversal? Root, left, right. That's pre-order traversal? Oh, okay. I guess you want to sort the children too? Algorithm, create a try from the given product's input. Iterate each character of the search word by adding it to the prefix to search for. After adding the current character to the prefix, traverse the try pointer to the node representing the prefix. Makes sense. Now traverse the tree from current pointer in a pre-order fashion and record whenever we encounter a complete word. Okay. Limit the result to 3 and return DFS once reached this limit. Add the words to the final result. Okay. I think I have an inkling what it's talking about. I'm going to look at the Java solution because I'm more well versed in Java. So you have a class try, which contains boolean is word, okay, marking the end of a word. And then you have a children, which is an array. Void DFS with prefix. So you have the current node and the string word. If result buffer dot size is equal to 3, oh, you're storing result buffer out here. Return, okay. If current is word, then result buffer dot add, and this is how you do the DFS. For every character C, oh, you literally iterate from A to Z, C++, A, C++, no pun intended. If current.children.get the current character is not equal to null, then DFS with prefix. Ah, I see. I see, that's how you would do it. And then inserting the string to the try, I was doing this, okay. Get the word starting with. Current is equal to root, result buffer is equal to new array list. Move the current to the end of prefix in its try. Get to word starting with. Wait, didn't we just do something up here related to that? That's the DFS up there. get the word starting with. Wait, what's the main idea here? So trie equals new trie. Result equals equal to array list. For every word in products, insert into the trie. String prefix is equal to new string for every character C. Search word dot to character array. Prefix plus equal to C. Result dot add trie dot get word starting. Oh, so this is the main function of that you're calling for each new character. Current node is equal to root. Your result buffer is this for every character C. In the prefix, if current children dot get, the current character I guess is null, return the result buffer. Okay. Current is equal to current dot children dot get C minus A. Okay, so basically if the trie node exists, get it, else return the result. Ah, I see. You're basically, you're starting from the root and then you're moving down to the trie node of your last letter, and then you run DFS with prefix on it. And then DFS with prefix is just this shtick. I see, okay, makes sense. Sick. I should probably try this sometime. Yeah. Alright, good to know. I feel like that's enough for today. I've definitely learned some stuff. Okay, I'm gonna end the stream then. Thanks to everyone who came. Thanks, Hello Gamer, for chatting with me. I appreciate. Yeah, see y'all next time. I'm probably gonna stream tomorrow. I'm gonna just stream some miscellaneous stuff. I'm gonna probably do a study with me stream. I'm gonna write it in a notebook, maybe apply to some jobs for fun, and maybe study some system design too. Yeah. Alright, see you guys tomorrow. Bye.